Hey there, algebra friends. Ready for some massive, amazing math today? Today, we're doing section 6.3, which means we're going way, way up now. We're taking multivariable linear systems, meaning, look at all these. I'm not just solving two equations and two variables. Whoa, look at that. 3 equations, 3 variables. Okay, we can do it. We've got lots of weapons at our disposal, right? We've got graphing. I don't want to graph 3 equations. We've got, let's see, graphing, no. We've got substitution, sure. Well, we got the new one, our elimination. And graphing, no, I just don't think so. It's going to be hard to graph in 3 variables. Substitution actually does work pretty well here, but really, since we like elimination, I think we're going to stick with that here. But first of all, can we make this look a little bit easier to solve? Because right now, I am scared. So, if we can make it look a little bit more like this. All right, that's still 3 equations and 3 variables, but can you see why this one looks a little bit easier? Oh, I see, because it's already solved for one of the variables. Yay! So if we know one of the variables, how can we figure out the other 2? Well, we can just back substitute, right? Let's work our way backwards and see if we can plug this back into and find y. And after we have y, we can take y and z and plug it back here and get x. Oh, let's try that. So let's take this one that we're talking about now, and let's try to back substitute. Now that it looks prettier like this, let's back substitute everything and see if we can solve for all the variables. So right now I've got z equals 2, and that's great. So if we plug z equals 2 into this equation, going up a notch, we should have y plus 3 times z is 2 now equals 5. Okay, that's y plus 6 equals 5, and if we subtract, we get y equals negative 1. Not too bad, right? Okay, why don't we take z equals 2 and y equals negative 1, and we'll plug those both back into the first equation and see if we can solve for x. All right, let's do it. We get x minus 2 times y plus 3 times the z we started with should equal 9. All right, that's really x. A minus minus is a plus 2 plus 6 equals 9. Once I move everything over to the other side that's non-x, I get x equals 1. Awesome. So we can write it like this as separate variables, or another cool way is we can write it like an xy point. But there's 3 variables here, so we can write it almost like an x, y, z 3-dimensional point. How about this? Final answer, 1, negative 1, and 2. It would be great if we had time to plug this in and see if it works. And as we said before, you always want to plug it into every single equation to make sure it works in all 3. Okay, so when it looks like this, oh, this is nice. We like this because it's so easy to solve. We can just back substitute, right? Okay, when it's not, all right, we've got to do some amazing math. All right, here is a good example of a 3-system equations here. 3 variables, 3 equations. Let's go. Notice over here, if you see in the second equation, that we don't have a z. So if you want to think of it as negative x plus 3y, and we could put a z in there, just to make sure there's none of them, so put a 0z. Almost like when we used to do placeholders way back when. So that's an idea of thinking of that. Okay, here's your goal. First of all, what I'm going to do is I'm going to number each of these equations. The top one is number 1, the second one is number 2, and the bottom one is number 3. Your goal is to keep using elimination until you can get all the way down to the bottom and have 1 variable and then just back substitute. So first goal is just choose any 2. Any 2 that you like. Really, it doesn't matter. Choose any 2 that you like, and you want to eliminate one of the variables. So here, I'll show you that I'm going to choose, can you see? I picked equation number 1 and equation number 2. Do you know why I picked those 2? If you can see that right away, if I use elimination, the x's will die right away. So that was a pretty good combo to choose. So I chose 1 and 2, and I eliminated x, and I was left with this. The y's added. The z's added. Remember, there was a 0z over here, so 3z plus 0z gives me 3z. All right, well, let's just let this one sit and chill. Now we have an equation of only 2 variables. If I can only just get one more like that with y's and z's, I can keep going. Well, let's try it. So your next goal is choose any other 2. Now, the important thing is, though, you want to make sure that you eliminate the same variable. If we eliminated x, over here we need to eliminate x. Don't eliminate a different variable. Let's try any other two and eliminate x. Now, it looks like I'm picking 1 again, but now I'm picking 3. Again, any pair that you want. You could have chosen 2 and 3 if you liked, as long as it wasn't the same as the original 2. Now, I have to get rid of x, right? If I got rid of x over here, I have to get rid of x over here. But the problem is they don't line up and cancel right away, right? So I'm going to have to mess with it a little bit. Can you see? What should I multiply this first equation by so that they'll be opposite coefficients and we can just add? How about negative 2? Shall we try that? So if I multiply the top equation by negative 2, I should get negative 2x plus 4y minus 6z equals negative 18. Okay? And I'll keep the second one the same. So now the first equation and the third equation have opposite coefficients. Let's add. They cancel. See ya. And I should get another equation in terms of y's and z's. Yes, that's great, because now I've got one equation with y and z. I've got another equation with y and z. We can solve these pretty easily. Let's bring these two together, and we'll do elimination one more time. So all in all, we do 3 eliminations in total. We do the first one over here to eliminate one variable. We do the second one over here to eliminate the same variable but with 2 other equations. And then we take our 2 answers and we do elimination one more time. But always make sure in these first 2 instances that you're getting rid of the same variable. All right, well, let's go down here and see how it works over here. Well, I can get rid of my y's really easily, right? Because they are opposites, so they're going to cancel. See ya. And I'm left with 2z equals negative 6. Great. Let's bring that over here, and now we can just solve for z by dividing, and we get z equals negative 3. Beautiful. Remember, we're not done then. We have to go back and plug everything back in and see how we do. Now, you can go back and you can plug into either this equation that had the y and the z, or this equation. It's really, really up to you. I'm going to take the first one over here and back substitute. So now we're going backwards and seeing how we're doing. I get, how about negative y minus z, which is a negative 3, should equal negative 1 according to what we said. That's negative y plus 3 equals negative 1. And therefore, y, once I move the 3 and divide or multiply by negative 1, I should get y equals just plain old 4. Great. All right, now we can take our y and our z and go all the way back. And really, you can plug them into any of these 3 that you like to solve for x. I kind of like the first one because x is just sitting by itself with no coefficients in front of it except a 1. So if we plug in everything there, we can just move it over and isolate the x pretty easily, I think. Let me make some room for that. All right, so here we go. We should have x minus 2, and check our y again. What was our y? It was 4, right? Minus 2 times 4 plus 3 times, remember z was negative 3, equals 9. So we plugged in 4 from our y, we plugged in negative 3 for our z, and this becomes x minus 8 minus 9 equals 9. And once we move everything over, I believe x equals something like 26. Okay, that looks pretty good. And if we go back and plug everything back in, you'll see it works. So those would be my 3 answers. Final answer, we would get 26, y was 4, and z was negative 3. And there's my final answer. So again, one more time. Choose any 2 that you want. Start there. And again, it could be any 2 that you pick. Maybe pick the ones that seem like if you add them right away, they'll cancel right away, whichever variable you choose. After you do that over here, go over here and pick another 2, any other 2 that you want, and eliminate the same variable. So we picked x's and we eliminate x's again. You take your 2 answers, which will only have now 2 variables, do elimination one more time. Maybe you have to manipulate and multiply 1 or 2 of them to make sure they cancel. And then once you eliminate, you're left with 1 variable. Solve for it, and you can just keep back substituting, back substituting, back substituting. You're good to go. So overall, the math is not hard, but as we go through one example, one more here together, big stars here. Okay, please just be careful. Watch your steps. There's no rush to go through these. Just watch your algebra, because you'll know one little mistake could really throw off the whole problem, and we don't want to do that. So just be really, really careful as you're doing this math here, friends. Ready? Last one. Let's do one more together. All right, 3x plus 2y plus 2z is 6. X plus 3y minus 2z equals negative 3. And x minus y plus z equals 4. 3 equations, 3 variables. Let's go. Let's do it. Okay, I'm going to rewrite it over here. Feel free, if you want to pause the video and try it on your own, go for it. Just go through the steps and see how you do. I do know for a fact that the answers to this are going to be all whole numbers, no fractions. And most of the times, I'll try to give you problems that will only have whole number answers, positive or negative, but I don't like to do fractions. Because once you see fractions, it kind of freaks us out, and we think, we did something wrong. So I'll try to make it all whole numbers as best as I can. Okay, you want to give it a try on your own? Go for it. I'm going to pause the video too and catch up in a sec, and we'll see how we did. Good luck. All right, friends, I'm back with all my work. Let's check and see how we did. So moving over here to the right, I did number my equations 1, 2, and 3. Don't feel like you have to do that, but it just organizes my work a little bit better. So over here, what I did is I took equation 1 and 2, and I noticed that it'd be really nice just to combine those and get rid of the z's. The z's canceled right away because they were opposite coefficients. I did that, and I got an equation here with just x's and y's. Cool. I let that sit and chill. And then following the green arrow this way, I decided to take then equations 2 and 3. Again, I have to eliminate z, though. And when I tried to do that, they didn't eliminate right away, right? So what I did is I moved over here, and I took the second equation, which equation number 3, basically, and I multiplied by positive 2. And this was my new system that I got, eliminating the z's, see you later. And this was my next equation in terms of just x's and y's. So we'll bring these two together. I brought my original back over here. And now I notice between these two, I think it might be easier to try eliminate y. So I'll take my top equation here and I'll multiply by negative 5. And now the y's match, so I got rid of them. And I got an equation in terms of x's. Yay! And I solved and I got x equals 2. Great. Then what I did is I took that and I plugged it back into this equation over here. I brought this over here and I plugged in x equals 2, solved for y very easily. And then I just went all the way back to equation number 3 that I started with, because that had z all by itself, plugged in x and y, and I got z equals 1. So my final answer right over here is 2, 1, it's 2, negative 1, and 1. And I'm just going to take 30 seconds and try to plug them in into all 3 equations just to see, and I'll put a little check mark. So I'm going to plug in 2, negative 1, and 1. And if I do that mentally, I get 6 minus 2 plus 2, it equals 6. Good. Now it has to work in all 3, right? So I'll plug into the second one. I'll plug in 2, plug in negative 1 for y, 1 for z. So I get 2 minus 3 minus 2. It actually does equal negative 3. Looking good so far, folks. Last one. I'll plug in 2 for x, negative 1 for y, and 1 for z. And I get 2 plus 1 gives me 4. And we did it. Great job. So like I said before, the best hint here is just be careful with your algebra. Every step you take, just be very extra careful so that you can solve it easily. Great job, and that's how we destroy these multivariable systems of equations using elimination 3 times. Great job, folks. We'll see you next time.